Every day we're hearing more and more about Azure Stack. Azure Stack, of course, is Microsoft's new hybrid cloud platform that enables you to deliver Azure services in your own data center. Since Kemp LoadMaster already provides advanced application delivery on physical appliances, bare metal, virtual, and cloud, it only makes sense that we would jump into Azure Stack so early to kick the tires. In this short demonstration, we will publish a Kemp LoadMaster to the Azure Stack Marketplace, deploy a LoadMaster through that marketplace, and look at a use case with a hybrid solution between Azure Stack running on-premises and Azure Public Cloud. Microsoft has really provided a lot of flexibility on publishing solutions to the Azure Stack platform. This process is building off of the Azure Resource Manager templates, or more commonly referred to as ARM templates. So to deploy a solution, the first thing we do is we need to download the Azure Gallery packaging tool. And when we download and extract this tool, we'll see the following folder structure. So to start off, we have our actual ARM template. So this template we put together, it's just a very simple template. It's going to deploy a single virtual LoadMaster in Azure Stack. But you could certainly extend this to deploy entire solutions if you wish. Then we have other directories, for instance, icons when publishing the solution. We also have a definition and the manifest file. The manifest file will show you the location of the ARM template, as well as some detailed information about the solution, as well as where to place this solution in the marketplace. So once you're happy with the content, what we can do is we can use the generator executable to package this into an AZPKG file. And once we have that file, we can leverage the PowerShell add Azure RM Gallery item to call that package and deploy it to the marketplace. So if I go into the marketplace and we go into the ADC options, we'll see we have Kemp LoadMaster ready to deploy. To deploy a solution in Azure Stack is no different than deploying it in Azure Public Cloud. Simply select your solution, and we just fill out the required parameters. Select or create a new resource group, and create. Most organizations today have a business critical application that's going to require site resilience. In this use case, we have a workload running on-premise in Azure Stack. It could be any application, but we want to make sure it's available in the event of a disaster. So we extend the environment into Azure's public cloud and leverage Kemp LoadMaster Global Load Balancing, or GEO, to provide automatic site failover. Looking at the Azure Stack environment, if we go to virtual machines, you see we have a virtual LoadMaster running in Azure Stack, and we have two servers that are running the workload, which in this case are just web servers. Looking at Azure's public cloud, we once again have a virtual LoadMaster running in Azure, and we have those two back-end web servers. And as you can see, the virtual LoadMaster in Azure's public cloud is running on IP address 52.186.120.144. So if we look at that virtual LoadMaster, we have a virtual service running on port 443, and it's publishing and load balancing those two back-end web servers. Going back to the Azure Stack environment and looking at the LoadMaster running there, we also have a virtual service running on port 443, and it's publishing and load balancing those web servers in Azure Stack. Going down to global balancing is in essence intelligent DNS, and it's monitoring the health and availability of these two locations. What happens is the clients will look up a URL, in our case workload.kempdemo.com, and the LoadMasters are responsible for resolving that IP address for them. Now, other use cases can be constructed that route traffic to both environments in a round-robin method or even based on the user's proximity. But in this configuration, we're leveraging fixed weighting. We're going to be sending all traffic to the Azure Stack on-premises environment on 192.168.133.25 since it has a weight of 1,000. Now, in the event that that site is offline, The loadmasters will then direct all traffic to Azure's public cloud on 52, 186, 120, 144, since that has a weight of 1. So let's go ahead and launch our browser. And we'll hit workload.kempdemo.com. And as you can see, we're hitting the Azure Stack environment. If I go and open up a command prompt, and we ping workload.kempdemo.com, you'll see we're resolving to 192, 168, 133.25. Now, if we go back to the loadmaster and simulate a failure, what we'll do is go into the virtual service and deactivate that service. So this is going to prevent any new connections from hitting this virtual service, and in that case, simulating what could be a complete site outage. So if we look back at the virtual services, we'll see that that is now in a disabled state. Looking at the global balancing, we see that that site is now marked as down. So going back, if we open up our browser and we hit workload.kempdemo.com, you'll see we're now being directed to Azure's public cloud. And if once again, if we go to our command prompt and ping workload.kempdemo.com, we're now resolving to the 52, 186, 120, 144. So with the combination of Azure Stack, Azure's public cloud, and Kemp LoadMaster, we're able to provide a hybrid solution with site resilience and immediate automatic failover in the event of any type of outage, including a complete site failure. This is just one of the many use cases where Kemp LoadMaster brings value to Azure and now Azure Stack. For more information, please visit us at kemptechnologies.com.